This video classroom lesson is sponsored by Transmission Bench. Visit the transmissionbench.com store for the deluxe super kit, other parts, and even the video classroom lessons used during this project.
I'm glad to have you back. This is Project 4L60E Part 2, Lesson 2. Our goals for this lesson are to inspect and prepare the case, install the reverse piston, output ring gear, low reverse clutch, rear planetary gear set, and roller clutch housing. You'll need small and large screwdrivers, 9/16 wrench, hammer, 1/4 inch socket and extension, 1/2 inch extensions, feeler gauge set, mechanics pick, a 4-inch long 3/8 by 16 bolt, slide hammer, a quart of transmission fluid, a shallow container, a squeeze bottle to dispense transmission fluid, a small bottle and eyedropper, transgel or bearing grease, and these 4 tools if you have access to them: a dial caliper, bushing driver, an engine intake valve, and a 1 7/16 inch socket. The actual assembly begins with an inspection of the transmission case. First of all, take a close look at all the bolt holes. If any are stripped out, you may need to install inserts to repair the threads. Check all the pan bolt holes. Check the pump bolt holes. All of the threads in this case look good. Make sure a check ball is in this location. It's not removed during disassembly and should be here after you clean the case. Look closely and you'll see 2 bent tangs to capture the ball. We need to check the servo apply pin bore for excessive wear. To do this, get the part of the servo assembly with the apply pin. Remove the apply pin from the servo piston assembly by removing this E-clip and sliding the shaft out. Put only the apply pin in the bore and push side to side and check for wear. As you can see, there is very little side play here. This case is okay, but make sure to look for any egg-shaped bores. There is considerable side thrust in this direction as the band is applied. A problem in this area is rare, but a worn bore can cause a pressure loss resulting in a burned band and/or 3/4 clutch failure. Reassemble the servo and place it back on the table. Another area to inspect is the check ball and capsule, which is installed into the case here. It looks like this. The steel ball must seal completely in the tapered area at the tip in order for the 3/4 clutch to work properly. To test it, place the case on its side like this. The valve body area should be level. Look closely into the channel casting here. You can see the check ball. Put a small amount of 50% transmission fluid and 50% mineral spirits into the capsule from the valve body area. the fluid will trickle into the servo bore, but it should not get past the check ball and its seat and leak into the case through this hole. If it leaks, the capsule must be removed and a new one installed. Although the capsule in this case did not leak, I'll demonstrate how to replace it. You'll need a 3 or 4 inch long 3/8 by 16 thread bolt, a wrench, and a slide hammer. Use a new bolt with sharp threads and screw it into the capsule. Use the slide hammer to pull the old capsule out. The new capsule is installed by driving it in with a 1/4 inch socket with the same outside diameter as the capsule. Drop the new capsule in. Use the socket, extension, and hammer and begin driving it in. Keep tapping until you feel it reach its seat. This is how it looks installed. Repeat the leak test to make sure the ball seals. I can't overemphasize how important this procedure is, so don't skip this test and replace the capsule if it's necessary. The #1 problem of the 4L60E transmission is 3/4 clutch failure. The cause is usually a leaking capsule or, as you'll see later, the piston in the 3/4 clutch drum. Finally, inspect the case bushing located here for wear. Replace it only if it is worn. Take note the bushing is installed about 1/16 of an inch below flush with its bore. Even though this bushing is okay, I'll show how to replace it. Mark it with a pin where the 2 notches are. Turn the case on end like so. Use a large screwdriver and hammer to drive the bushing out. Tap evenly on one side and then the other. Try not to destroy it by hitting only hard enough to get it moving. Turn the case over. The new bushing must be installed from inside the case. This is a tool designed specifically to drive a bushing in. Here's the new bushing from the bushing kit. Notice the notches face this way. Start the bushing in the bore. Line up the notches with the pin marks. I use a 1/2 inch extension to reach it. Drive it in with a hammer. Make sure it's driven in about another 1/16 of an inch past flush with the case. An alternative is to drive the bushing in with a 1 7/16 inch socket or a valve. A small block Chevy 1.94 inch intake valve works fine. After driving the bushing in with the socket or valve, recess it the additional 1/16 of an inch by placing the old bushing on top of it and drive it in a little bit further. We'll install the low reverse piston next. Get it from the bench. Remove the 3 seals. It's not uncommon to find them crystallized and hard as a rock from heat. Use a small screwdriver to break them off if you have to. Put the old seals where the piston was in case you need them for comparison later. Locate the low reverse seals from the overhaul kit and install them. Lubricate them lightly with a product such as Transgel or bearing grease. Put lubricant in the piston bore where the 3 seals move against the case. It is okay to use bearing grease, but use just enough to make the bore slick. Notice the indentation located here. It corresponds to this tab on the piston. Put the piston in. Use the output shaft to tap it down. The fit is pretty snug. Tap on one side and then the other until it bottoms out in its bore. Get the spring cage and the snap ring. Put the spring cage in. Use the spring compressor to compress the cage. Install the snap ring. Remove the tool. Get the output ring gear, hub, and thrust bearing. Inspect the ring gear for any cracks. Check to make sure the bearing is not damaged and turns easily with no chattering. Use a small container of transmission fluid to pre-lube it. Notice that the thrust bearing fits on the hub one way. The side of the bearing with the inner lip must go against the hub. It will not fit this way. Put fluid on the hub journal. Place the bearing in the case. Place the ring gear and hub in the case. It should spin easily like this. Get the rear planetary gear set and the thrust bearing that goes between it and the output ring gear hub. Inspect the thrust bearing. Pre-lube it with fluid and make sure it turns freely. The side with the lip fits against the gear set, so place the bearing in the output hub like so. Inspect the 4 planetary gears for excessive in-play and needle bearing damage. If you are working on a 4L65E or 4L70E, there will be 5 gears. Notice how badly this gear rocks back and forth. It obviously has needle bearing damage. Make sure that you carefully inspect all of the gears. All of these Planet gears have needle bearing problems. Check all the gears carefully. I typically will find 3 that are good and 1 that is bad. Even if one of the gears are bad, the gear set must be replaced. Now let's look at a healthy remanufactured Planetary. Notice how I cannot rock the gears at all. Check them all. These feel great. Check the in-play with a feeler gauge. There should be no more than 25 thousandths. I measure about 11 thousandths here. Pre-lube all the gears with fluid. Now let's check the thrust washer inside the Planetary. First, pre-lube it like this. Get the sun gear from the bench and install it like so. Turn the sun gear while pressing down to make sure the bearing feels okay. It should turn smoothly with no rough spots or chattering. This thrust bearing is actually new because the gear set has been remanufactured, but always check them like this anyway. One last note about this bearing: it cannot be removed unless one of the pinions is removed. Place the Planetary in the transmission like this. It should also turn freely. Installation of the low reverse clutch pack is next. It consists of 5 frictions and 5 steel plates and a wavy cushion plate. Get the old pack and set it near the case. Get the new frictions and steels from the master kit. The wavy cushion steel is the last steel to come out during disassembly and the first to go back in. You can see how wavy it is when you look at it like this. Without this plate, reverse engagement would be very harsh. All reverse steels, including this wavy one, have a notch on one tang to help you index it with the case. Install it with the notch towards the left and the tang down at the 6 o'clock position like this. Let's take a look at the old clutch pack. Since it appears to be in like new condition, we'll use it as a reference to compare the new parts with. The low reverse friction plate thickness is 87 thousandths for all years. I'll use a dial caliper to check them. I'm measuring 89 thousandths, which is correct after allowing for swelling from transmission fluid. Let me check one of the new ones. Without any fluid on it, it measures 87 thousandths. Friction plates should not be installed dry. To prepare them, pour fluid into a shallow container and dip the clutches into it. Let the excess drip off and set them aside with the new steels. We need to pay closer attention to the steels because of variations. First of all, there are 2 styles. One type, used from 1993 until about 1997, has no holes in it like this one. The other, a turbulator type, has 4 oval-shaped holes and is used from 1997 and later. As you can see, Our old and new replacement steels are the turbulator type. Both types are completely interchangeable, but use the turbulator type for better fuel economy. The holes introduce turbulence to counteract the parasitic drag caused by the fluid film between the plates when the clutch is not applied. Not only are there two styles of plates, there are also three different thicknesses. The most common steel is 67 thousandths. Let's measure our old ones. It's 67 thousandths. Most of the time, you'll find that all 5 flat steels will measure 67 thousandths. Let's check the new ones. They measure 67 thousandths, so they'll work fine. There are 49 thousandths and 89 thousandths plates available, which are 20 thousandths thicker and thinner respectively, to adjust in play if necessary. Let's install the clutch pack into the case. Remember, the wavy steel has been installed. Place the first flat steel in. The notch goes to the left, tang at 6 o'clock. Now place a pre-soaked friction in. Its splines will fit on the planetary housing. Put another steel in. Notch to the left and at 6 o'clock. Put a friction in. Keep alternating steels and plates until you have installed 5 steels and 5 frictions. The last plate should be a friction, as you see here. Reach in and rotate the planetary and feel the slight drag. Get the low roller housing, case snap ring, and the case silencer from the small parts box. The last assembly to install during this lesson is the low roller clutch housing. But before we do, let's inspect it. Listen to this sound. This screeching sound usually indicates that the one-way roller clutch is healthy, but you should always disassemble it and make sure. Set it so the friction plate side is facing up. Remove the inner race by turning while pulling it out. Note the inner race turns counterclockwise. Use a small screwdriver to remove this snap ring. Set it to the side. Mark the housing and the spring cage because the cage can be installed incorrectly upside down. pull the cage with the rollers and springs out. Inspect all of the accordion springs very carefully. Look for any broken springs. Make sure they all have even pressure on the rollers. There is a repair package available which includes new rollers and springs. Our assembly is like new, so we'll reassemble it as is. As I said before, you can accidentally install the roller and spring assembly upside down and backwards. Here's how to install it correctly. The springs should always be pushing the roller up the ramp. Place the cage in the housing part way. Put some fluids on all the rollers. Install the inner race by rotating it while pushing in. Push the spring cage all the way in. Look on the other side to see if it's all the way in. Replace the snap ring. While holding it in your left hand like this and the smooth friction surface facing you, you should be able to rotate the inner race counterclockwise with your right hand. It locks in the other direction. Set the assembly down for the moment. Tilt the case slightly towards you by placing something under the case. Place the case silencer in the case like so at the 5 o'clock position. Now we can set the low roller housing in. Look for the wide notch here to index it with the case. Push down on the housing. Installed correctly, the housing and silencer should look like this. If the silencer is not in place, install the output shaft and push everything forward and start over. Rotate the inner race while pushing down until it engages the planet carrier. The last step is to install the case snap ring. Begin by placing one end here. Push it in with a screwdriver. Check to see that you have some in-play in the reverse clutch pack. Use a mechanic's pick like this and make sure you have about 60 thousandths play. If you have very little or no in-play, you have probably installed one too many friction or steel plates. If you have excessive play like 1/8 of an inch or more, then you probably have left a plate out. If you have any doubts about how you stack the clutch, disassemble it and check it. The most critical aspect to look for is that the clutch pack is not too tight and can freewheel easy when the clutch is off. You can apply air pressure to this port with a blowgun and watch the low reverse clutch apply. Keep the pressure down to about 40 psi. This concludes Lesson 2. In Lesson 3, we'll install the rest of the rear half of the transmission.